Hello everybody, tonight's flipped homework is going to be on a point slope form refresher, and we're going to cover questions from page 58 to 60 in your workbook. So we should be on page 58, and we'll move around a little bit like we've been doing, and the ones we don't do we will do in class as practice. So as a reminder, we should definitely highlight, circle this, and even write it out for ourselves one more time. So point slope form is y minus y1 equals m times x minus x1. We have to have this memorized, rock solid in our brain. It's going to be the biggest tool in the toolbox for the next couple of days in looking at some real-world applications. So to remember how it's used, let's get right into this first set of practice. It says, write a linear function in slope-intercept form using the given information. So notice, we're supposed to write in slope-intercept form. Slope-intercept is y equals mx plus b. So the way that I keep them straight is the name actually tells you what information it contains. So slope-intercept has m and b. See? mx plus b. Whereas if I look here at point slope form, that's going to have a point x1, y1, which will be some point on the line. See, x1, y1, and then slope m right here. So the name tells you exactly what the equation contains. So if I look at number 1, it says I'm given a slope of 8, so that's a value for m, and a y-intercept of -5. That's a value for b. So here, that worked out really nice. To write the linear function in slope-intercept form, I've got m, I've got b, so y equals 8x minus 5, and I'm all done. Let's take a look at number 3. Number 3 says slope of 4, which is m, and now I've got passes through this point. This is a point on the line, so I can label that x1, y1. And as soon as I see I have slope and a point, right away I see that my only option right now is point slope form, which again is y minus y1 equals m times x minus x1. And I'm going to write it for myself as a guide. The more we write this, the more we'll remember it. Y minus y1 equals m times x minus x1. Lines on the equal sign. And now let's plug in values. So what we can plug in for is, let me highlight it for us. I can plug something in for m, and then my ordered pair gets plugged in for x1, y1. So let's do that. I've got y minus a -1, because that's a -1. This already comes with a negative, equals 4 times x minus 6. But if we read the directions say I'm trying to get to slope-intercept form. So that means I have to solve for y. So from this point forward, we're really just going to rely on our solving skills to get y by itself. So let's see. Minus minus turns into a plus, so I have y plus 1 equals, and then this 4 outside the parentheses we can distribute. So 4 times x is 4x, and then 4 times -6 is -24. Still trying to get this y value by itself, so let's see. I have a positive 1 here. I know I can subtract this over. And I get y equals 4x. -24 minus 1 is -25. And we're all done. Because we accomplished slope-intercept form, which is y equals mx plus b. Let's see. Number 5, again, I'm given a slope, which we will label as m. and passes through this point. So I know that this is going to be x1, y1, and our guide will be point slope form, because that's what I have. I've got a point on the line, a random point, and the slope. So y minus y1 equals m times x minus x1. Please press pause on the video and you try setting it up, and then we'll compare. So let's see what you had. When I start plugging in my values, I want to make sure I account for these built-in negative signs. So this will be y minus a -3, and I choose to write it separate just so I see it, equals 1/2 times x minus -8. And from here, we need to solve for y. Minus minus turns into a plus. I'll leave this 1/2 on the outside for now, and that becomes x plus 8. I have some work I can do on this side, so I'm going to, again, leave y plus 3 alone for right now, and let's distribute this 1/2. 1/2 times x is 1/2 x, and 1/2 times 8, there's two ways to think of it. We could either just know straight away that half of 8 is 4, or we can see this as 1/2 times 8 divided by 1. And when we multiply fractions, I'm just going to rewrite that a little neater, we get 8 divided by 2 when we multiply straight across, which equals 4. So however you like to see it, but it's definitely a plus 4. We're super close. Again, we're trying to get this y by itself. So my last step would be to subtract 3 from both sides. And I get y equals 1/2 x minus, or excuse me, plus 1. Now in number 7, take a look about what's different about this. Here, I'm just given 2 ordered pairs. So definitely not going to be using slope-intercept form. When I have 2 ordered pairs, I need to calculate slope first. So let's see. The change in the y values will be 9 minus 7 divided by 1 minus a -1. That'll get us 2 divided by 2 equals 1. So if you need to pause there to finish calculating slope on your own, no problem at all. Go for it. Press pause. So I've got slope and I've got points. So our strategy is going to be point slope form. Pick one of the 2 points to use for x1, y1. Both of these ordered pairs are on the line because it says the line passes through these points. So you get to pick which one you want to use. To guide me, I'll always write y minus y1 equals m times x minus x1. And if I can avoid negatives, I will. So I choose to use this one. So I'm going to circle it so I make it clear that's what I'm using. I'm going to put a line down the equal sign. So this is going to be x1, y1. So I've got y minus 9 equals 1 times x minus 1. So I plugged in the slope that I just calculated. That went in for m. That's where the 1 came from. And then I chose to use 1 comma 9. So y1 became 9, x1 became 1. And from here, we need to just solve for y. So press pause, and please, you finish solving for y, and then I will solve for y, and we'll see if we match. So press pause. Distributing this 1 won't actually change anything, so I get y minus 9 equals x minus 1. And to solve for y, again trying to get this y by itself, I'm going to add 9 to both sides. And I get y equals x plus 8. And we're done. So this is the strategy when I'm just given 2 ordered pairs. The only thing I can do with that to start is actually calculate slope. I've got 2 points and slope, so that lends itself to point-slope form, where you get to pick. If you had used -1, 7, you should end up at the exact same equation, no matter which point you chose on the line. All right, let's go and take a look at the bottom of page 59, where it asks you, so I'm going to show you what I'm talking about. Leave 9 and 10 alone. If you want to try those, you can, but not as part of our notes. We're going to come down here to the bottom of page 59 and talk about how we're going to approach real-world scenarios now that we've warmed up our skills. In a real-world scenario, our first step will always still be to define variables. Second, we are going to identify m, which is our slope. Make a note, slope formula, which, just to remind you, change in y divided by change in x, y2 minus y1 divided by x2 minus x1 if 2 points given. So if I'm not given the slope and I have to calculate it, I might have to do this work. Just giving you a second to write if you need a little more time, and making this a little neater. So we've got our variables defined, we've identified slope or calculated it if we needed to. Now we have to ask ourselves, are we given the y-intercepts, also known as initial value? And this is going to really be important, because if I'm given the y-intercept, it's going to be nice. So step 4 is going to be like a split. So if we're going to have like a yes and a no for y-intercept given. It's going to influence what we do next. If it's a yes, we can go straight to write y equals mx plus b. Because if we got our slope in step 2, if I'm given the b value, either from the graph or I see initially there was, right? If it gives me the starting value, I can just go straight to writing y equals mx plus b. If I'm not given the y-intercept, we're going to be using our point slope skills. So write y minus y1 equals m times x minus x1 and isolate or solve, but we're going to upgrade our language. Make sure you say the word isolate y. And last but not least, once we've done that, answer any follow-up questions using y equals mx plus b, because that's the form you'll have. So I guess you could say like 4 and 5 kind of go together. Slide this down. Based on whether or not you're given the y-intercept. So these steps you'll have to reference for all of our real-world practice. Let's take a look at our first real-world scenario. It says the bar graph in this figure, here's our bar graph, gives the life expectancy, so how long a person will live, for American men and women born in the indicated year. So here's 1960. The darker column is males, lighter column is females. So we're saying like in 1960, the average life expectancy for a guy was roughly 66 years old, and for a woman, approximately 73. Then if I look over here, by the year 2007, look at the increase. Now men are expected in 2007 to live to about 75, and women approximately 80. The data for the men are displayed as a set of 6 points in this scatter plot. So over here, so notice it's a scatter plot because this data has been plotted raw, and it's not necessarily linear. Okay? That's why it's a scatter plot, and the points might not look like they're all on the line. Also shown on the scatter plot in this figure over here is a line that passes through or near the 6 points. So like this one is definitely all the way through. This one's kind of close. That one's near. By writing the equation of the line, we can obtain a model for life expectancy and make predictions about how long American men will live in the future. So this trend line trends with the data we have. And if we find the equation of this line, we're saying we can actually keep predicting for other years based on this data. So let's see what our directions say. It says, write the slope-intercept form of the equation of the line shown in this figure. So first, our first step, define variables. So let's do that. X equals and Y equals. And when I have a graph, it's super nice because I can actually pull it straight from the axes. On the x-axis, it says X is the birth years after 1960. So X is birth years after 1960. So for example, my 0 year is 1960 because we're 0 years after 1960. 10 years, this would be 1970, right? 20 years would be 1980. 30, 1990, 40, 2000, and then 50, 2010. So notice 2010 is not here, right? But if I follow this 50 all the way up, that's not what I have data for. The data here is plotted a little bit before 2010 at 2007. My Y value represents life expectancy. Measured in years. So we've defined our variables. Let's see. Next, that next step was define our variables, identify M. So let's see if we're told a rate of change in our real world scenario. I'm rereading it right now. I know that I have 6 points plotted. There's a line that goes through those points. But nope, nowhere in what's written am I told a rate. Like the age increased by this many years per year. Nowhere do I see per each or every or any kind of rate. But what do I see on the graph that I can use? Here's one point. Here's the other point. Calculate slope. I can calculate the slope. So let's do that. I'm going to record those points. So 20, 70 and 40, 74.3. And if you don't have your calculators out, you're definitely going to need them. So if you want to press pause to go get your calculator, that would be awesome. And we're going to calculate slope just like we have our average rate of change. Change in Y divided by change in X equals, if you need to, just to jog your memory, you can write the slope formula down. And after you write the slope formula down, if you need it, please press pause on the video and you calculate the slope yourself. And then we'll see if we match. I'm going to get out my calculator too. So press pause, you do it and I'll do it, and then we'll compare. So I'm doing 70 minus 74.3 divided by 20 minus 40. So if I use my calculator, 70 minus 74.3 gets me negative 4.3 divided by 20 minus 40. I'm doing this like I'm pretending like I'm you. Use your calculator if you need it. 20 minus 40, which gets me negative 20. And then let's see, negative 4.3 divided by negative 20 gets me a positive 0.215. And if I get some labels on here, my Y value is life expectancy, so 0.215 years per year after 1960. So every year after 1960, people lived for 0.215 years longer. And if I were to multiply that, just fun fact, multiply that by 365 days in a year, that ends up being, if you can see this, maybe, 0.215 times 365 means roughly 78 days. So every year after 1960, men lived roughly 78 more days each year. Very cool. Now, I've got my slope, but that's all I've got. I definitely don't have y equals mx plus b yet, because slope-intercept form is y equals mx plus b. That's my goal. That's what I'm trying to get to. Now, in our steps, it said, just as like a reference, once I calculate my slope, which I just did, we have to reason, are we given the y-intercept? If not, we have some work to do with point slope form. But let's go back and see if it gave it to me. So let me look here. My initial life expectancy is going to be in this 0 year. Initial value when x equals 0, what's y? So if I look, I have to ask myself, do I know what this is? Well, the answer would be no if I didn't have this bar chart. But I've got the bar chart. So in 1960, I know that men lived 66.6 years. So that means that this ordered pair is 0, 66.6. So we do have the initial value given to us. Initial value 0, 66.6. So when we go to write y equals mx plus b, I've got m, here's m, and we just said that this is b. So writing y equals mx plus b is y equals 0.215x plus 66.6. And I'm going to change y to be f of x, just because it's a little bit more useful for evaluating follow-up questions. I'm right about at the 23-ish time for our notes. So I'm just going to take one more minute, not even, to just discuss real quick how I would answer this follow-up question, and we'll be done with our notes. It says, use the equation to predict the life expectancy of an American born in 2020. So first I have to ask myself, is this a value for x or y? When I come up to my variables, x is birth years after 1960, and y is the life expectancy. I don't know life expectancy, but this is a year after 1960. So value for year after 1960. But I can't say 2020, because if I say x equals 2020, if I try to say this, no good. Saying 2020 years after 1960. That's not what we mean. I need to do 2020. Oops. I'm actually going to put it as part of my formal work. the year 2020 minus 1960, if you're not sure what it is, use your calculator. So 2020, I'm going to pretend like I'm you, putting it in right now, just so you know. Come on, plug it in. 2020 minus 1960, and I get 60. That is the value for x, because we're saying 60 years after 1960. So let's evaluate f of 60 and see what we get. 0.215 times 60 plus 66.6. And I can plug that, once I write it out like that, I can just literally plug it in exactly as I see it and get it right into the graphing calculator. I mean, sorry, not graphing calculator, just regular calculator. 0.215 times 60 plus 66.6, and we get as an age 79.5. So using this model to predict the age of men in 2020 yields an answer of 79.5 years old. And that wraps it up. So that's it for our notes for tonight. If you have some time and you'd like to go try some of the ones we didn't talk about, we will be picking up on those in class tomorrow. Have a great night, everybody. And any questions, if you do practice some on your own, please don't hesitate to send me a question on Remind.